Hi all of you. So already we discussed the current electricity is divided into 10 parts. In that first part is electric current, about the electric current and their applications. We will discuss very clearly what are the topics we are going to discuss in electric current. So we know that one, part 1, we know that one, electric current. In this electric current, first we will discuss about the average electric current and instantaneous electric current. And next one, what are the applications of electric current? We will discuss clearly. And what is the drift velocity and the relation between drift velocity and electric current. And next topic we are going to discuss, that is relaxation time. What is the relaxation time? Okay, denoted by tau, it is. And the relation between drift velocity and relaxation time. And next topic is mobility, that is denoted by mu. Mobility means how easily an electron can move in a conductor. That is defines the mobility. We will discuss clearly here what is the mobility, what is the formula, it is depends upon which factors. We will discuss very clearly, right? Now next one, current density here. What is the current density? Denoted by J bar. Actually current density is a vector quantity, right? Actually what is the current density and what is the formula for this one? And it is depends upon which factors. We will discuss very clearly each and every part in electric current part 1 topic, right? Average current, application of electric current, drift velocity and drift velocity I relation, relaxation time and drift velocity relation, and mobility, okay, as well as current density. These are the topics we are going to discuss now, right? Right. Okay, so first we will discuss about the electric current as well as average electric current and instantaneous electric current, right? So generally first we will discuss about the electric current. It is denoted by small I or capital I also. So actually what is the electric current? What is the current actually? So generally we know that one, that is flow of electric charge through any cross section of the conductor is called as a electric current. Actually what is the charge here? Charge nothing but electrons. Okay, so generally charge nothing but we will consider as here what? Electrons only. So charges are here what? Positive charges will be there, negative charge will be there, right? So positive charge means magnitude of the charge. For example, if you see this is the one conductor, this is the one conductor, means one wire here, right? So for example, through this conductor a current I is flowing. If you consider nothing but something charge can be moved here what? In this direction. So in a time interval of t seconds, nothing but, so cross section of the conductor is how much? A, we can see that. Nothing but the rate of flow of electric charge. This is considered as a conductor. Conductor nothing but the materials which allows the electric current through them. Of course, based upon the electrical properties, materials are classified into 3 parts: conductors, insulators and semiconductors. Conductors nothing but they can allow the current. Insulator nothing but there are not possible to flow of current in the insulators. And as well as in semiconductors they have here what? Both properties. So we have a separate chapter is there, semiconductors. We will discuss very clearly about the semiconductors. But if you see here what conductors, okay, they can allow the current through them, right? So in conductor of cross section, right, in a wire of cross section A, if a charge Q is passing from here to here in a time interval of t seconds, that is defined as here what? Current I is equal to Q by T, we can say that. Q by T means how much charge is flowing from one end to the another end of the conductor in a time interval of t seconds. This is called as here what? Electric current. Of course, electric current is equal to total charge by total time also we can say that. That is total charge divided by total time. Total time here. Right? So total charge nothing but number of electrons, that is here what? N. Charge of each electron is E divided by total time nothing but T. Like this also we can say that. N is the total number of electrons, E is the charge of one electron. Okay, so total charge N into E divided by in a time interval of t seconds. This ratio gives here what? How much current is flowing through that conductor. Through that conductor. Of course. Now here what? Charge we can say that. We know that one little bit here what? Q. Q is nothing but charge. Q is nothing but here what? Charge. So generally charges are here what? Two types. Positive charge and as well as here what? Negative charge. Okay. Positive charge nothing but they can say here what? Protons. Negative charge nothing but here what? Electrons. But charge of this proton here nothing but we can say that okay, charge of one proton or one electron, okay, one electron is equal to minus negative charge nothing but that is equal to minus of 1.6 into 10 to the power of minus 19 coulombs. This is denoted by C also. Right? Similarly, charge of one proton that is equal to, right, plus 1.6 into 10 to the power of minus 19 coulombs. That is also here what? C. Means P means here what? Protons. Okay. E means here what? Electrons. E means here what? Electrons. Like this. For example, how many electrons are passing from one end of the conductor to the another end? We can say that. Okay, same number of protons can move from one end of the conductor to the another end of the conductor. So like that we can define a charge may be positive, may be negative. Positive charge nothing but protons, negative charge nothing but electrons. Okay, charge of one electron, how much charge of one electron? That is 1.6 into 10 to the power of minus 19 coulombs. Electron have the negative charge, nothing but minus 1.6 into 10 to the power of minus 19. Proton has a positive charge, that is plus 1.6 into 10 to the power of minus 19 coulombs. So this is the way, just a little bit here what we can discuss, or we can say that electric current is equal to Q by T, nothing but, so I is equal to total charge by total time, that is equal to number of electrons, charge of each electron by total time it is taking. This is about a little bit here what? About the charge here. Okay, so this can also be written as here what? In shortcut way, that is like this. What is the formula for electric current? So that can be here what? Defined or like this. For example, here you can say right here what? Q and here what? T and it is here what? I. So I is equal to Q divided by T. That is the way we can write. current formula. And if you want to write the Q is equal to, charge is equal to product of current and time, and T is equal to, that is equal to Q by I. Like this we can define. Okay, electric current Q by T, Q is equal to I into T, T is equal to Q by I here. This is one of the way to remember the formula of electric current. So total here what is the electric current? Electric current nothing but the rate of flow of electric charge through any cross section of the conductor. Once again I repeat, what is the electric current? The rate of flow of electric current or electric charge through any cross section of the conductor, that is called as here what? Electric current. So electric charge nothing but Q. Total how much charge is flowing or crossing from one end of the conductor to the another end of the conductor in a time interval of t seconds. So like that we can define the electric current. Basic concept and basic formulas are also. Okay, so I explained very clearly. First understand this one and we will go to the here one, average current. What is the average current and what is the instantaneous electric current we will discuss. Okay, next we will discuss about the average current. Of course, average current nothing but average electric current or average current, that is I average is equal to total charge by total time, we can say that. Nothing but delta Q divided by delta T. This is also written as here what? Q2 minus Q1 by T2 minus T1. It is also written as here what? Total charge, okay, crossing through that ends of the conductor divided by in a time interval of how much. This is the average current. And as well as what is the instantaneous current. Instantaneous electric current or current. Instantaneous current denoted by here what? I instantaneous. Okay, instantaneous current is nothing but actually if the charge is flowing through the conductor continuously with a different time interval, then current can also be different in a different interval of time here. But if you want to find the electric current at a particular instant of time, at a particular interval of time, okay, so this instantaneous current will give nothing but delta T, okay, limit delta T tends to 0, nothing but at a particular instant of time, that is nothing but here what? Delta Q by delta T, that is equal to dQ by dt here. Actually this is the limit nothing but within the time interval, very short interval of time here, nothing but that is nearly equal to 0, then this total is written as here what? dQ by dt. For example, Q is given in terms of time. Find the instantaneous current, nothing but we have to differentiate that charge, right? With respect to the time, we will get the instantaneous current. At what time he is asking? For example, time t is equal to 2 seconds or 3 seconds. Yes, we can find by differentiating the charge which is given in the question with respect to the time, and thereby finally if you substitute the value of time, we will get the instantaneous current at that particular instant of time here. So these are the formulas for the average current as well as instantaneous current, right? Note down it. One more formula is also there for the average current, that is I average. This formula we will use in the alternating current. So what is the formula for the current? Actually charge by time only, na? Total charge nothing but, okay, so I into T, we can say that integration of T1 to T2 I into dt divided by total charge in a time interval of T1 to T2. Okay, total time nothing but that is T1 to T2, that is here what? Dt. This is nothing but what? Here Q only, na? Q divided by time. But this Q is equal to what? I into dt. Nothing but here what? In interval of here what? T1 seconds to T2 seconds. Okay, so the current is given in terms of time. Then if you integrate the current in terms of time, okay, so the limits are here from T1 to T2 seconds. So this is the another formula to find the average current. Average current. Okay, I average is equal to integration of T1 to T2 I dt divided by integration of I1 to I2 dt. This is also one of the formula for the average current. Maximum we will use this one. Of course, we will use this one also, but about this one we will discuss in the current in alternating current. Right? So instantaneous current formula this is. Note down. Okay. Next, what is a SI units of electric current? What is a SI units of electric current? SI units of electric current. So we know that one electric current is measured in amperes only. Okay, in amperes. SI unit is what? Amperes. Ampere denoted by capital A, and according to the formula we can write it as here what? That is what is the I is equal to what formula? Q by T only. According to this one we can write it as Q by T. Q is what? Coulombs. Okay, coulomb divided by time. Nothing but that is T, nothing but time. This is also written by C by coulomb by seconds also we can write. That is second. This is the way. Coulomb per second, otherwise C by second. Another one here what? Okay. Other one amperes. Maximum we will use amperes only. Sometimes we can use here what? Coulomb per second also. Okay. SI unit of electric current is amperes or coulomb per second. Coulomb per second. According to the formula, coulomb per second. So generally here we can define, okay, in the terms of here what? Amperes only electric current. Okay. Actually electric current is a most important. This is scalar quantity or vector quantity. So actually electric current has a magnitude as well as here what? Direction. Nothing but whenever the conductor is connected to a one potential difference, then only the charge can be moved in a particular direction. So thereby we can say that the current can be moved in another direction. Right? So current has a direction as well as specific magnitude here. So we can say that a quantity or if any physical quantity which has a magnitude as well as direction, that is called as a vector quantity. But here electric current has a magnitude as well as a specific direction, but the electric current is not a vector quantity, it is a scalar quantity only. Scalar nothing but it has a magnitude, okay, and it does not have actually direction, but it has a both magnitude and direction. But to obey the vector property, it should be follow the here what? Law of vector addition also. Law of vector addition also. That property is not followed here. This is the electric current. What is the law of vector addition? Actually, so it is a scalar quantity. Scalar quantity. Okay. Even though electric current has a specific direction and specific magnitude. It is not a vector quantity, it is a scalar quantity. Why it is? Why it is not a vector? Why it is a scalar? It does not obey the law of vector addition. What is the meaning of law of vector addition? For example, if you see for example, this is the one junction, we can say that J. Now the current is coming towards the junction here, what? I1, and another current is here, what? Coming toward this junction from this direction, that is equal to I2. What is the angle between these two currents? Consider as here, what? 60 degrees or whatever, maybe 30 degrees. Okay. Now here, whatever the current is passing from this junction, that is equal to, I am considering here, what? I3. Nothing but the angle between the two input currents I1 and I2 is 60 degrees. Then outgoing current is equal to I3 here. We know that one. For example, if I1 is equal to 1 ampere, I2 is equal to 2 ampere, I3 must and should be 1 plus 2 ampere, that is equal to 3 amperes only. It is independent on angle between these two currents. This is only difference, or this is defined, or this can be found directly by adding these two currents here. Of course, about this concept we will discuss in the Kirchhoff's laws. Whatever the currents are here coming towards this junction, that should be equal to sum of these two currents here, what? Away from this junction. Directly we can add these two currents. It is independent on, this is independent on angle between these two. For example, another way here. For example, the same current is here, what? Like this, I1 is equal to 1 ampere, and this here, what? I2 is equal to 2 amperes, and this is the junction. Consider toward the junction I1 is coming here, toward the junction I2 is coming 1 ampere, same magnitude I am taking, 2 amperes this is. But the angle I am changing here it is 90 degrees. Of course, even though the angle between these two currents here, what? 90 degrees, the current which is coming out from this junction, that is I3, always is equal to 1 ampere plus 2 ampere, that is equal to 3 amperes only. It is independent on angle between the two conductors, right? So that is the reason why electric current is a scalar quantity, because of it does not obey law of vector addition. Only one the reason, it is independent on angle between the electric currents. It is only depends upon the here, what? Magnitude of the electric currents only, right? So that is the reason why it is a electric current is a scalar quantity, not a vector quantity. Remember, once again I repeat, as per the concept, electric current has a specific direction and as well as magnitude. So it should be here, what? Vector. But it is not a vector, it is a scalar quantity. Why? Because it does not obey the angle between the two conductors. Outgoing current, output current is sum of the input currents only. That is directly we can say that, directly we can add up this one. It is independent on angle between these two. So that is the reason why it is a scalar quantity, right? So average electric current, instantaneous electric current, and SI unit of electric current is amperes, denoted by capital A. Actually, it is the fundamental physical quantity. Or as per the formula, I is equal to Q by T. Q means here, what? Charge. Charge is measured in coulombs. Time is measured in seconds. So coulomb per second is a SI unit another way. And it is a scalar quantity. Okay, little bit about the average current and instantaneous current. Okay, no doubt enough. Okay. we will discuss another part, that is application of electric current. Applications of electric current, most important. See, this is applications of electric current, most important. General formula is what? Electric current, I is equal to what? Q by T. Average current, we can say that is equal to delta Q by delta T, nothing but total charge by total time. Instantaneous, okay, current is equal to dq by dt. At a particular instant of time, how much charge is flowing through the conductor, that is given as here what? Instantaneous current, of course. So first one here what? These formulas can be used here what? In how many different ways? That is number one. First, number one. See, for example, an electric current is flowing through the, for example, a charge is flowing through the conductor, okay, from a t1 seconds to t2 seconds, right? So then how we can define the current here? For example, current changes through the conductor. For example, this is the one conductor, okay? Through this one, current is flowing here, I. This current is changing with respect to the time continuously. Then how much charge is flowing through this one? Nothing but, that is I is equal to, we know that one, dq by dt. Okay, whenever the current is flowing through this conductor, that is I. Okay, so how much charge is crossing from this conductor, one of the conductor end to the another end of the conductor? So how we can find the charge here? So from this formula, dq is equal to I into dt, we can write. From here to here, charge from here to here, right? So this is the t1 seconds to t2 seconds. Charge is flowing from, okay, so one end of the conductor to the another end of the conductor. So if the current I is flowing from here to here in a time interval of t1 to t2 seconds, right? So then how much charge is flowing from here to here? That is we are going to find. So according to this formula, dq by dt, right? dq is equal to I into dt, we can write. If you integrate on both sides, right? In a time interval of how much? Time is changing from t1 seconds to t2 second. Integration of dq, nothing but that is equal to q. That is equal to integration of I into dt from t1 time seconds to here what? t2 times. So this is the formula, first one. Right? Once again I repeat, this formula when we will use, current is given in terms of time. Then find the how much charge is flowing through the conductor in a time interval of t1 seconds to t2 seconds. If they are asking like that, we have to use to find the charge. Okay, so q is equal to integration of t1 to t2 I into dt. We will see the problems, right? We are going to discuss the problems also based upon this each and every formula here, right? Understood all of you? Current is given in terms of time and they are asking how much charge is crossing through that conductor in a time interval of t1 to t2 seconds. So to find the charge, this formula is useful. Most important, this is q is equal to integration of t1 to t2 second I into dt. They will give, for example here, they will give, okay, for example, I is equal to 2t square plus t, like this. Means current is changing with respect to the time. Means if you change the time here, current will change or not. For example, time t is equal to 1 second. So 1 second means here what? 2 plus 1 here. Nothing but total current is what? 3 amperes. Nothing but At time t is equal to 1 second, how much current is flowing to this conductor? That is equal to 3 amperes. At time t is equal to 0 seconds, 0 here also the 0, current is equal to 0. Like that, of course. So that is the way current is varying with respect to the time. If it is given like this, right? So then they will ask, okay, from t1 seconds, nothing but 0 seconds to time 2t is equal to t2 seconds, how much charge is flowing through that conductor q. So how we can use this there, right? So q is equal to, therefore q is equal to integration from t1 to t2, means in between, right, 0 to 2 seconds is asking the charge, 0 to 2 seconds, and I into dt. What the I here? 2t square plus t into what? dt. Okay, this is here what we are going to do, integration of t square plus integration of t. Thereby we will get the, by applying the limits, we will get the charge. We will discuss with one example problem. This is also one of the problem. If you want to do here, what you can do? Integration of t square, we know that one. 2 into integration of t square, nothing but t cube by 3 we will get. Apply the limit upper and lower, plus integration of t, nothing but t square by 2. So thereby we will get, by applying a upper and lower limits, we will get the total charge, okay, from 0 seconds to 2 seconds in the conductor when the current varies by this way, right? So there is a formula. We will discuss one problem after the completion of some applications, right? Okay. Now, according to this formula, if you see, this is called as here differentiation. Means to get the current, we have to differentiate the charge with respect to the time, right? So what is the meaning here? To get the current, okay, we have to differentiate the charge, okay? Differentiate the charge with respect to time t. Okay, by differentiating the charge with respect to time, we will get what? Current. If you see here, to get the charge, we have to do the what? Integration of the current here. Means here, what is the meaning here? To get the charge, integrate the electric current. Integrate the electric current. Okay, right now, to get the charge, we have to integrate the electric current. To get the current, we have to differentiate the electric charge. This is the right. Clear? No. Right? Right now, application 2 we will discuss. That is application number 2. Application 2 is nothing but whenever a charge Q is revolving in a circular path of radius r, okay, in a time interval of here what? T seconds, for example. What is the meaning? A charge is revolving in a circular path of radius r. With what speed? V1, we can say that. With speed of here what? V. For example, this is one circular path of here radius r. That's considered here what? This is the one electron, nothing but charge, nothing but electron we are considering. Now, the electron is revolving in a circular path with what speed or velocity here? This is the velocity here, what? V. Velocity of the electron is, direction of this one is here. So it is moving in a anti-clockwise direction, that is like this. with speed v and frequency here what f of the circular path radius r here. Okay, of course this is, we can say that charge q also, this is equal to what? Charge. Now in this case, how we can define the current and velocity, whatever the formulas, right? See, for example, when a charge is revolving in a circular path of radius r with a speed v and frequency f, then if the charge completes one revolution, how much distance it can be traveled here? That is equal to circumference of the circle of this one only. Nothing but that is the distance covered by an electron or charge, okay, for one complete revolution, complete one revolution. That is equal to nothing but circumference of this circle only, that is equal to 2 pi r here. Right now, this is denoted by here what? D here, that is equal to 2 pi r. The distance covered by electron for complete one revolution, that is equal to 2 pi r, of course. Okay, so how we can find the speed of the charge? In the circular path? Now, v is equal to, speed is equal to distance by time, we know that one, that is here what? T. What the distance it is covered in a time interval of 1 second, means one revolution, that is equal to 2 pi r by t. So formula we got here, therefore v is equal to 2 pi r by t is the formula for speed. One formula, right? Now so t also we can write from this one here what? T we can write, t is equal to 2 pi r by v here. Right? So this is the point 1. Okay, what is the point 2 here? Application number 2. When an electron when a charge is revolving in a circular path of radius r with speed v and frequency f, then the distance traveled by this charge or an electron, okay, for one complete revolution, that is equal to what? 2 pi r only. From the speed is equal to distance by time, that is equal to how much distance it is covered in a time interval of t seconds, that is 2 pi r by t. So speed is equal to finally 2 pi r by t. We can write t is equal to, we can write it as 2 pi r by v. This is the way we can find the time if they are given. So by substituting the time, we will get the value of speed of that charge in a circular path. Of course, point number 3, nothing but third application if you see, that is current, we know that one, current I is equal to Q by T. Okay, T is nothing but here one, time taken by the charge to complete one revolution. Okay, Q by T. So we know that one, that is where F is equal to 1 by T only, frequency is equal to 1 by T, nothing but 1 by T, nothing but here what? Q into F or not. So electric current in terms of frequency and charge, we can write it as here what? Q into F. Sometimes we have to use to find the formula, okay, value of current. Okay, so this is the frequency and charge multiplication. And another way how we can modify this one, that is see, that is equal to here what? I is equal to Q by T we can write. Of course, where we know that one, that is, okay, so omega is equal to 2 pi by T, we know that angular velocity of the a charge in a circular path, omega is equal to 2 pi by t. Angular velocity nothing but angular distance or angular displacement by here what? Angular distance by time here. So 2 pi by t, therefore t is equal to, how we can write? 2 pi by omega here. But reciprocal of this one we can write as omega by, okay, of course. So this can be written as here, okay, omega, nothing but q omega by 2 pi. So finally current I is equal to q into omega angular velocity by 2 pi. This is the formula for electric current another way. Okay, in terms of frequency, in terms of your angular velocity of the charged particle. Q omega by 2 pi, Q into F. Another also here, we can write it as here another way, that is, of course, so that is I is equal to Q by T, but actually T is equal to what here? 2 pi R by V, if you do the reciprocal of this formula, right? So I is equal to Q into V by 2 pi R. So this is also one of the formula to find the electric current. In terms of speed and charge, in terms of charge and frequency, in terms of charge and angular velocity. These are the current formulas in a different okay, form here. Frequency and charge and angular velocity, charge and okay, speed of that one, right? So these are the first application we completed, and second one, this is the third one. Third nothing but whatever the electric current is there, that is in different forms, how we can write this the way. Okay. First one completed, application number 1 completed, number 2 completed, number 3 means formula of current in a different form here. And application number here what? 4. Application number 4. What is the application 4? See, for example, graph if you see. Okay, the area under the IT curve or IT graph gives electric charge. What is the meaning here? The area under IT graph gives electric charge. Electric charge, that is Q. What is the meaning here? For example, this the x-axis. On x-axis I am taking here what? Time. On y-axis I am taking here what? Current. One curve is given here what? Graph, nothing but curve. This is given like this. This is equal to what? 0. Time t is equal to 0 seconds. If the curve is up to here, this is the time here what? T seconds. Okay, the current is varying here. If you see here what? Current is varying like this from t 0 seconds to t seconds. Area under this curve of IT gives here what? What is the electric current? Electric charge. How we can define? Charge is equal to integration from where to where here? 0, right? So current is varying from where to where? Time 0 seconds to t seconds. Nothing but 0 seconds to t seconds. Okay, so current is varying nothing but I into dt only. Like this we can find the charge, okay, by using the graph. Area under the IT curve gives here what? Electric charge. We know that one, that is here. Another way also we can say that. For example, if the curve is here what? Like this, constant current and time is from here to here. For example, if it is here what? 5 amperes of current, this is equal to here what? 5 seconds. Right? 0 to 5 and 0 to 5 seconds. So how we can find the charge here? Q is equal to, okay, actual formula is what? I into what? T1 in a current formula. What the I here? That is equal to 5 amperes. that is equal to that is equal to 5 into, right? So how much time it is taking? 5. That is equal to 25 coulombs. Okay, 25 coulombs. Like this also we can find area under the, okay, given curve gives your what? Charge. If it is like this, okay, so 5 amperes current from 0 to here and 5 seconds. But the current here 5 amperes, and how much time it is taking? That is equal to what? 5. So total how much charge? 25 coulomb. If it is not like that, this is the constant current here. This is what here? What? Constant current. Current is not changing with respect to the time. Okay, constant current, if it is taking here what? Like this, we can find the charge. If the current is changing continuously with respect to the time, okay, then we can use this formula to find the charge. So finally, area, right? Area under the curve of IT graph gives here what? Electric charge. This is one of the application of electric current. Another, okay, that is equal to fifth application, that is a slope of QT, okay, graph gives, okay, electric current, that is I. So what is the meaning here? For example, this is the here what? X-axis. This is equal to what? Y-axis. On X-axis I am taking T. On Y-axis I am taking here what? Charge. Right? Now if the curve is given like this, and this is equal to what? Theta. Now how we can find the slope of this one? Therefore, slope of this curve is equal to, or graph is equal to, that is we can write it as a tan theta is equal to, tan theta nothing but here what? If it is like this, this is here what? Tan theta, charge, opposite side charge, adjacent by adjacent nothing but time, nothing but Q by T. We know that one Q by T is what? Current only, na? Right? Slope of QT graph, right? So our curve gives here what? Electric current. This is the way. Slope is equal to tan theta. Tan theta is equal to Q by T. Q by T nothing but indirectly, that is nothing but electric current only. So finally, area under the I and T curve gives electric charge. These are the formulas. And the slope of the QT curve gives here what? Electric current. This here. If the current is constant here, that is the formula. If the current is vary with respect to the time, so this is the formula we can find to find the charge. Right? So these are the applications of electric current. Okay? Fourth one and fifth one. Note on it. Right. One more. Sixth application and important. What is that one? See here. Application number 6. It's important. Try to understand here. Sometimes they are asking the conceptual question regarding this concept. What is that one? See, for example, if you see, this is the one conductor, nothing but one wire here. This is the one conductor. Okay, so conductor. Okay, so now if it is, okay, connected by a one battery, that is like this. Okay, so battery nothing but it is a positive terminal, it is a negative terminal, it is applies a potential difference of, for example, V. If it is a positive, this is the positive. If it is a negative, this is here what? Negative. In a conductor, lot of free electrons will be there. In a conductor, lot of free electrons will be there. For example, I am considering one electron here, that is like this. Right? So when you apply a potential difference of V across these ends of the conductor, then this electron will move in which direction? Tell me. Okay, actually if this conductor is connected like this to the battery, so the direction of the current is what? This is the direction of the current. This is the direction of the current. And we know that one, if the charge is plus Q, the electric field is away from this one. And if the charge is negative, the electric field is here, towards the negative charge. If the charge is positive, electric field is away from it. If the charge is negative, electric field is towards it. This concept, we know that one in the electric charges and fields chapter. See, based upon that one, if the charge is here, positive charge, and here one, negative charge. Electric field, external electric field, by applying a potential difference of this one, from where to where? Positive to negative only, na? For example, if it is here what, plus Q, and here what, negative charge minus Q, the electric field is always from, okay, plus Q to minus Q only. If it is here what, plus Q, if it is here what, plus Q, okay, so the electric field is in this direction from positive charge to the negative charge. This is the direction of electric field. Okay. Electric current in this direction, and as well as electric field is also same direction of current. Right. This is one of the point. Next, for example, what happens to the electron? This electron or this charge can be moved here what, in which direction? In this direction or in this direction? Obviously, if it is a positive charge, okay, so positive charge will attract the negative charge because of electron has the negative charge. Now here what? This electron can move in this direction. Already it is a negative, negative will repel. So electron can, okay, so pull toward the positive charge, right? So this is moving from negative charge to the positive charge. Okay, so electron is moving left, okay, left side, nothing but opposite to the electric current as well as electric field. See, one more point we are going to discuss here. For example, how we can define the positive charge and negative charge. For example, to get the positive charge, we have to remove the negative charge from that body here. Right now, you know that one, what is the concept? To get the positive charge, we have to remove some electrons from that bond. Right? Otherwise, negativity, if you remove from the body, automatically the body will get here what, positive charge. See, from the cross section, right? This is the another, right? Understand here. This is the one conductor. So from this cross section, this is the one cross section. This is the one cross section of the conductor, that is DA, right? So, for example, from this cross section, one electron is moving in this direction. Okay, so whenever the electron is moving in this direction, nothing but electron is here what? Negative is removing from this area. Nothing but automatically from this one, right? Proton will move in this direction or not? How many electrons are crossing from this area? The same number of protons will move, or protons will cross from this area opposite to this one, right? So electrons will move in this direction. How many number of electrons are crossing from one end to the another end of the conductor? Same number of protons will move from positive terminal to the negative terminal. Means electrons can move from, okay, right to left, and as well as protons can move from, okay, left to right. So most important, if you understand here, right? Right. See, electron motion is opposite to the direction of the current as well as electric field, but proton can move, or direction of the protons is along the direction of electric current and electric field. This is the important point I am going to discuss. Right? I want to discuss, this is the point important. Means finally, electric current, direction of the electric current, direction of the electric field, okay, direction of the protons are same. Whereas here what direction of the electric current is, or electric charges or electrons are here what opposite to the electric current and electric field. Right now? So I and E and protons are in the same direction, but electron is opposite to this one, right? If the battery is connected with this polarity. This is the concept of your sixth application of electric current. Of course, some more points and some more concepts we will discuss about this one later. But these are the most important six applications of electric current. Right now, so based upon these applications, we will discuss some problems in this part 1 only. Clear? Okay. So up to here, we discussed about the electric current and their applications. And regarding electric current, formula of electric current and their applications means different forms of electric current formulas we discussed, right? So based upon the formula of electric current, we will discuss some example problems. Thereby you will get a clear idea, right? So first one, example problem number 1. Example problem number 1. So nothing but, so they will give here one 10 to the power of 7 electrons are crossing across the conductor. Okay, how many electrons are crossing here? 10 to the power of 7 electrons are crossing across the current, okay, conductor. Then, okay, so what is the current they may ask, and what is the okay, in a time interval of something here, 1 second or 1 hour, whatever it may be, right? So time is equal to 1 second here. So nothing but in a conductor 10 to the power of 7 electrons per second, okay, crossing. Nothing but this is the one conductor. Across this conductor, okay, how many electrons are crossing? N is equal to 10 to the power of 7 electrons are crossing here. Whenever the electrons are crossing from here to here, then what is the current here? Current I is equal to what we have to find. So 10 to the power of 7 electrons per second they are giving. So per second means 1 second here. So then therefore current I is equal to, we know the formula, Ne by T. Okay, N is nothing but here number of electrons. Number of electrons are how many? 10 to the power of 7 is given in the question. Right, E means charge of 1 electron. What is the charge of 1 electron? 1.6 into 10 to the power of minus 19 coulombs divided by time. So what the time it is taking here? 1 second. So that is equal to finally 1.6 into 10 to the power of, right? So 19 means 10 to the power of minus 12. Okay, amperes of current is flowing here. This means across the conductor 10 to the power of 7 electrons per second if it is crossing, then the current flowing through that conductor is equal to 1.6 into 10 to the power of minus 12 amperes. Okay, this is the one example problem number 1. Right, problem number 2. Problem number 2. What is the question, right? For example, charge is given to you. Charge Q is equal to T square plus 2T, right? So then they are asking here 2 questions in this question, right? So first one here what they are giving, given here what? Charge Q is equal to T square plus 2T coulombs, of course. Means charge is given in terms of time. Means charge is varying with respect to the time. So in this he is asking number 1, question number 1, find the current, right? Current is equal to what? At time t is equal to 2 seconds. Okay, at time t is equal to 2 seconds, So he's asking here what is the time? What is the current? Sorry. So now here what? Number 2, second question. In a time interval of 0 to 2 seconds, what is the average current? What is here? Average current. I average is equal to what? Okay, from t is equal to 0 seconds to, okay, t is equal to 5 seconds. T is equal to 5 seconds. So these are the two questions they are asking if the charge is given like this. So question number 1. What is the question number 1? I is equal to 1 at time t is equal to 2 seconds. Q is given, first only we discussed it. Okay, when the charge is given in terms of time, to get the current we have to differentiate the current charge. Nothing but current I is equal to, what is the formula we have? dq by dt. dq by dt. We have to differentiate this charge with respect to the time. So d by dt of q is nothing but t square plus 2t. Okay, sir. This is equal to differentiation of t square with respect to the t, nothing but 2t. That is 2t plus differentiation of 2 is a constant as it is, differentiation of t with respect to the time t, nothing but here, that is equal to 1. That is equal to 2t plus 2 is the, okay, current. Current is like this. But at what time it is asking the current? At time t is equal to 2 seconds. If you substitute t is equal to 2 seconds, then we will get the right. So at t is equal to 2 seconds, therefore current I is equal to 2 into 2 plus 2. That is equal to what is? So 4 plus 2, nothing but 6 amperes of current is passing. This is the problem number 1, means question number 1 solution. Next, but the next question, okay, that is 2. Average current is asking. How we can find the average? Okay, can you remember the formula of average? Average current nothing but total charge by total interval of time. Time interval is given 0 seconds to 5 seconds. Total charge we have to find. How we can find the total charge? Charge this one q at 5 seconds, right? So minus q at 0 seconds, right? How we can write the formula for just first here? What we will write the formula? I average is equal to q at 5 seconds minus q at 0 seconds by t at 5 seconds, means t minus 0 only. Okay, this is equal to, right? So how we can find the value of charge q? Okay, so q5 means at time 5 seconds. This is equal to q square t square plus 2t. In place of t we have to substitute 5. So that is equal to 5 square plus 2 into 5. That is equal to 25 plus 10. That is nothing but here what? 35 coulombs. Okay. What about the, okay, so q0 means here what? If you substitute here what? That is, therefore q, this is at 5, this is equal to 0. Q at time t is equal to 0 means this is equal to 0, this is equal to 0, total charge is 0. That is nothing but 0. Right? Q at 5 seconds, 35 coulombs. Charge at 0 seconds, 0. Time already is given 0 to what is 5. Nothing but directly we can write as 35 by, total charge is how much? 35 minus 0 by t minus here what? 5 minus 0. That is equal to 35 by 5, that is equal to 7 amperes. So I average value is 7 amperes. So this is the average, average current of value, and this is the instantaneous current, of course, at time t is equal to 2 seconds. These are the basic and simple problems regarding applications of electric current. No doubt. Okay. Next question, question number 3. That is our problem number 3, we can say that. What is the question number 3? Now just before in question number 2, charge is given. So they are asking here what time. We can use the formula of that is. But if the current is given in terms of time, then also they will ask here what charge here. What is the formula for this? Well, actually what is the given question, right? So the given here I is equal to T square plus 1 means current is varying in the conductor with respect to the time. Okay, as a function of time, I is equal to T square plus 1. So in this, they are asking here what? Question number 1. Okay. What is the question number 1? Okay. Find the charge, right? So find the charge. Q is equal to what? From where to where? From time t is equal to 0 seconds to time t is equal to that is 2 seconds or whatever, 2 seconds. For example, 3 seconds we can take, right? Now, what the question number 1? Find the charge or Q is equal to what? Okay, so from time t is equal to 0 seconds to time t is equal to 3 seconds. This is the question number 1. Next, question number 2. So, how many number? For example, this much of current is flowing and this much of charge is flowing. Then find the how many number of electrons are crossing across that conductor. Charge, you know that one. Okay, how many, right? So the charge, you know that one. How can find, right? The number of, how many number of charges, okay, can cross the conductor. Means number of electrons we have to find, right? Find the number of electrons, that is nothing but n value in the same interval of time. In the same interval of time. Same interval of time. Time nothing but 0 seconds to 3 seconds. Okay, sir. How we can calculate? So first one, number 1. Charge, how we can calculate? So we know that when current is given in terms of time, we have to find the charge. What the formula? Can you remember? Right? So Q is equal to integration of T1 to T2 I into dt. This is the formula. Right? What the formula? What is the formula? Q is equal to integration from T1 to T2 I into dt. This is the formula, we know that one. That is equal to, right, time is given from where to where? 0 to 3 seconds. Nothing but integration from 0 to 3 seconds. I is given as T square plus 1. Okay, into what? dt. Into what? dt. So we have to differentiate of this one. Integration of, I can write the formula here. Integration of x to the power of n is equal to x to the power of n plus 1 by n plus 1 is the formula. So integration of t square nothing but okay, so t to the power of, what does it mean? 2 means 2 plus 1 by 2 plus 1 nothing but t to the power of 3 by 3 is the answer, right? So that is t cube by 3. Upper limit is what? 3. Upper limit is 3 here. Lower limit is 0. Okay, it is clear. Now plus integration of 1 into dt. Nothing but that is equal to t. That is t, that is E3, 0. Integration of constant is equal to t only, right? Integration of t square, t cube by 3. This is the formula for this one. Now if you substitute in place of your t, 3 here. So 3 cube means 3 into 3 into 3. That is nothing but how much? 27. 27 divided by 3. If you substitute here the word 0, we will get 0. Nothing but 27 by 3 is the value of this one. Plus, what the value of here? In place of t, we have to substitute upper limit 3 minus 0. Nothing but here we will get 3. Clear? Okay. So 3 ones are 3, 9. Right? So finally 9 plus 3 nothing but 12. What is the formula, right? So this is the coulomb. So charge, how much is flowing here? That is the 12 coulombs. That is 12 coulombs of charge is flowing across that conductor if the current varies Okay, with like this. And one more question is also asking here. What is that is? Number 2. We have to find the number of electrons in value in the same interval of time whenever the charge of this one is crossing across the conductor. How we can find? So what is the formula for the current? I is equal to Q by T. We can say that Q by T. So we know that one another formula, Q is equal to N into E only na? Yes or no? This can be written as here what? Okay, so N into E, we know the formula of that is this one only na? That is I is equal to Q by T, that is equal to N E by T only na? But we have to find here what? This one. Nothing but we can write it as Q is equal to N into E. But we have to find N only na? Therefore N is equal to Q by E. Okay. N means here what? Number of electrons. Okay. What is the E here? Charge of electron. What is the charge? Total charge is crossing here 12 coulombs. Nothing but 12 divided by E. E means charge of 1 electron. What is the charge of 1 electron? 1.6 into 10 to the power of minus 19 coulombs. If you do this one, we will get here what? 7.5 into 10 to the power of, okay, 19 electrons. 19 electrons. So this much of number of electrons, 7.5 into 10 to the power of 19 number of electrons can be crossed through that conductor when a charge of 12 coulomb is crossing. This is the solution for these two problems. We know the formula of this one. We will discuss in the applications of electric current, and we know the current, okay, formula of this one also. We discussed about this formula. But application of these two formulas in this problem like this. Okay, one more problem based upon the application of electric current. That is problem number 4. So try to understand what is the problem, right? See, for example, this one conductor is given. This is the one conductor, nothing but one of the wire here, right? Across this conductor, okay, number of electron density, right? Number of electron density N is equal to 10 to the power of 29. Okay, electron density means electrons per, number of electrons per unit volume, we can say that. Free electron density also we can say that. Free electron density. Free electron density is given of this conductor. Okay, right? So current passing through this one, I is equal to 2 amperes. Length of the current is given as here what? Okay, 4 meters. And area of cross section of this conductor is given as here 1 millimeter square, right? So then how much charge can be, okay, so flows in a time interval, right? To cross the charge, okay, to cross the number of electrons in what time? In what time? This is the question, right? What is the question? See, one conductor is given to you. Area of cross section of the conductor is 1 millimeter square. Current passing through this conductor is how much? 2 amperes. Length of the conductor is given as here what? 4 meters. And then free electron density is also given here what? N is equal to 10 to the power of, okay, 29. This is not your number of electron, this is the free electron density, right? So free electron density N is equal to free electron density. Free electron density, nothing but number of electrons per unit volume here. What? Number of electrons per unit volume here. What? Unit volume. Okay, so we will discuss about this one in the next part. But N is given as 10 to the power of 29. So time we have to calculate. So how we can calculate the time here? See, actually what are the values are given here? Length is given as 4 meters. current is given as here what 2 amperes, area of cross section is given as here what 1 millimeter square, and number density is given as here what 10 to the power of 29, and time t is equal to we have to find. These are the first to find, right? So this formula we will discuss later, but we will here discuss, right? What the relation between current and drift velocity, we can say that. So drift velocity, okay, Vd into E into N into A. About this one we will discuss next. Okay, what is the drift velocity and what is the relation between drift velocity and electric current, right? In the next part, means part 1 only, we will discuss the next concept of this one is, right? So relation between drift velocity and electric current. What is the I? We have a derivation also, we will discuss derivation of this formula also. I is equal to drift velocity ENA. About every, okay, of this one we will discuss clearly. Then I value is given, E means charge of electron, N means free electron density, this value, A means also given. So Vd is equal to, how we can write, I divided by ENA we can write, that is equal to, what is the I here, 2 amperes of current, E means charge of electron 1.6 into 10 to the power of minus 19 into N means 10 to the power of 29, area of cross section. Here the area of cross section 1 millimeter square means millimeter square to meter square we have to write, nothing but 10 to the power of minus 6 meter square we can write. Now this is equal to 10 to the power of minus 6. So final value of Vd is equal to, we will get after the calculation of this one, that is 1.25 into 10 to the power of minus 4 meter per second velocity, drift velocity of the electron in this conductor. Now what we have to find actually, time only, na? So to find the time, right? So time t is equal to, what is the formula? Distance by, actually velocity is for the formula, where velocity is equal to distance by time. Time is equal to distance by velocity, we know that one. Right, so time t is equal to distance, nothing but here how much distance here, what length only, na? That is equal to L. Right now, from here to here, the electron should be cross here. Nothing but what is the distance here? Length of the conductor only. Nothing but length of the conductor is the distance traveled by the electron to cross the conductor. Right? So what is the V here? Drift velocity of that electron. Now, what is the length of the conductor? 4 divided by, what is the drift velocity is given? Okay, we already find out there is a 10 to the power of minus 4. If you calculate this one, we will get 3.2 into 10 to the power of 4 seconds. So in a time interval of this much, okay, the total charge can be crossed through this conductor. This is the way we can derive or we can find the value of time period. So no problem, don't worry about this formula, we will discuss very clearly in the next part, right? Relation between current and drift velocity. What is the drift velocity? What is the free electron density? All we will discuss in the next one. But related to this one, we have a one question, okay, so that we can solve like this. Time t is equal to 3.2 to the power of 4 seconds finally. So this is the value. So thank you one and all. I hope all of you understood this concept. If you have any difficulty or if you are not understanding properly in anywhere, so you can chat. Okay, so once again, thank you one and all, and subscribe the channel and share the topic of this one, and we will continue the topic in the next. Thank you and all.